Hello? 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 Okay. Yeah, that's good. I should have set it up before I came here. Oh, and also I should have pricked my opossums. Okay. Got to do my thing. Okay. Phew. Here goes nothing. Hi. Today we're gonna be solving some math problems. This is the only way I can do my homework. Okay. Today's picture that I drew is what did I draw? I drew Chio from Azumanga Daioh. In the middle, this is from the scene where she dresses up as a penguin, and she does her stretches, and then she falls down. And I think I forgot to talk about this. I think I did talk about it. Osaka. Basically, I don't know, it doesn't look too bad. It looks pretty bad. Whatever, it doesn't matter. Okay. On the camera. This look good. Hold on. See your message. Yeah, so today's not a gameplay. Today's not a video game day. Oh crap. Oops. I wasn't supposed to do that. Okay. Today I'm going to do some math homework. And I thought I would just leave it. Can't get this thing right. Okay. Is it like this? Is this right? I should have set this up beforehand. Okay. Whatever, that's probably good enough. Yeah, so there's no video game today. I'm supposed to do my math homework. Okay. Calculus 3, so I have to solve the Laplace transform. I asked you how you're doing today. I hope you're doing well. Okay. Yeah, hopefully my work isn't too hard. I hope so too. Oh no, should I be doing this? Maybe it's a little silly. That's why I could do homework on stream. Oh crap. Oh well. Okay. Today we're gonna learn about the Laplace transform. And the problem is I don't know anything about it, or I know a little bit, but not enough. I have to read this textbook. And you know, my goal is to be able to teach it. To be able to teach the skill, or not even teach a skill. Just like figure out how to do it. look here. Talking about derivatives. So you know that d over dx squared equals 2x. You're studying, so you're studying that stuff, and then you have to learn about the linearity property. So that means that d over dx a f of x plus beta of x. Okay. This is the linearity property. A f prime of x beta I never added letters to math. Yeah, you're right. And you're supposed to take the integral alpha f of x plus beta g of x derivative dx. No, that's not derivative, that's just dx. Equals a f of x plus beta g of x. So this kind of thing isn't really me teaching it, it's just me trying to figure it out. And I work more productively when I just work more productively when I hit that stream button, I think. Or at least I do it. Like, I wasn't gonna do my homework, so now I have to do it. So this means that I think alpha is just like a constant, so it can be like 1, 2, 3, or any other number. And this is the function of x, and when you take the integral, you can separate them into two different integrals, and you can factor out the a. So like pretend like a is 3, or these are the same, so oh crap. So like alpha could be like 2 or 3 or any number, and then you just pull it out and you take the integral of the function. So I have to remember that. And B and A. So I'm just writing down what I see in my textbook. I don't know if I'm allowed to share the textbook or like put the textbook on the screen because it's like copyright issues. Anyway, I doubt it matters, but better safe than sorry. Guess. Maybe not. X. Okay. What this means is oh no. I don't know what it means. Take the integral starting from B to A. You do this. Yeah, you can take out the alpha and take the function. So it's basically the exact same thing up here, except you can take the from the limit or something. This is useful to solve. Would be useful to solve the Laplace transform. Yeah, I can't let them get a peek of the $100 textbook. Actually, this one was free because in university they got like some kind of website. Okay, the problem is I don't know how to do integration, I forgot. By holding y constant, we can see that they're saying that 2, 1, 2, x, y squared, dx equals 3y squared. I don't know why. First of all, I already forgot how integration works. Okay. Yeah, I'm not gonna lie, this isn't gonna be very entertaining and there's gonna be a lot of moments of silence when I try to figure it out. So I wouldn't blame you if you, you know, you want to spend your time somewhere else. You, just saying. Oh, whatever. First I need to go look up integration. Want to support me. Thank you. Very nice of you. Okay, I might have to review my techniques of integration. Okay, if you take the integral of x10 dx, that means that I understand that when you take the integral, it goes up by 1, and then you have to divide by 1 over. Because when you take the derivative, you multiply it something. Knowledge of derivatives. Easily write down a number of antiderivatives. Okay, move this over here. Okay. Hard to see. So I should remember that here, some basic derivative rules or integration rules. X equals xn plus 1 over n plus 1 plus c. So basically that means that if you take the integral of, I don't know. Oh yeah, that does make sense, because if you take the integral of like x9, it would be 9 plus 1, so x10, and then n plus 1 where 9 is n, so it would be n plus 1. Would it be n plus 1? Over 10? Yeah, that makes sense because it's 1 over 10 x to the power 10. Okay, yeah. That works. That makes sense. Take the integral of x to the power of -1 dx, you get the natural logarithm of x. And you get the, if you take the integral of e dx, it always becomes ex. Oh, and don't forget the plus c. The integral of ex is always the same. The integral and the derivative. You're gonna learn that soon, or maybe you already learned it. I started learning calculus in when I was in grade 12. Negative cos x. Yeah, okay. Okay, I definitely understand that. Okay, can I put this down a little more? Okay, I need to check my camera. Go it down a little more. Turn it like this. Oh. How did I do such a good job before? Before I had like the camera like at the perfect angle. Okay, well, whatever. Here. Okay. Yeah, still. Whatever. It's too bad. Okay, what was I gonna do? Okay, integral of cos x dx equals sine x. Yeah, I knew that. Integral of secant squared x dx equals tan x. Okay. The rest of them I don't really remember. Okay. Now, Some derivatives are not so simple. Substitution 2x cosine x squared dx. Application of the chain rule. The derivative of the inside function. And run the rule. Okay, hold. I read this stuff. D over dx sine x squared equals cos. Even when the chain rule has produced a certain derivative, it's not always easy to see. Okay. Gotta focus. Function. Okay. D over dx. No. That's all wrong. X cubed minus x squared dx minus 2x minus 1 over 2. 1 minus 1 minus x squared. Oh, hello people. Hello to other people. I'm trying to figure out the rules of integration. I know the title said, does anybody know the Laplace transform? But if I can't even do the integrals, I'm not figuring this stuff out. So now I have to go back to the basics. I had a lot of trouble with calculus too. So that's why my integration is really bad. Okay. Function f of x whose derivative is okay. Okay, so this is just use substitution. So all you have to do is just calculus 2. Yeah, calculus 1 was hard too. Okay, you do this and you do those 1 minus x squared. Then you do du. It's like this, right? dx, and this equals 1. 1 is 0, or 0 minus 2x dx, and then what do, you divide it like this. Done. Get du over dx equals negative 2x. Okay, yeah, that makes sense. This would still be dx. That wouldn't be right. That wouldn't be right at all. Okay. H. X cubed minus x squared root like this, x cubed u x is 2x. Okay, but where did it come from? u for dx x. Because obviously these two stuff cancel out, right? This. Oh, camera's not even in focus. Okay, what if I move in a little like this? Okay. Alright. Same as our current expression. Now we're almost. Wow. No coincidence. Alright, yeah. It's a silly mistake. Okay. Any paths to. Okay. Find the antiderivative or evaluate the definite integral. You can use Sage to help check your answers. Okay, why don't we do something over there? Okay, this one looks easy. 1 minus t 9t. So all you have to do is, you can't do this, so you have to say 1 minus t equals u, then du equals 1, equals 0, equals minus 1. Okay. Yeah, that makes enough sense. That makes enough sense. So, what does this mean? I don't know. It means that this is dt over here. Then you're gonna have to take dt and okay, so it's minus 1 dt equals du. That means you have to divide this -1 down here, -1. This goes away and you just have dt. And you have dt over here. So basically that means that if this is equal to this becomes dt, or dt becomes that, and this also becomes u power 9 du over -1. And then you're supposed to factor out the -1. Okay. u9, because otherwise if it wasn't du you wouldn't be able to factor it, or you wouldn't be able to use integration. So now this is a simple integral. It's 10, it's 1 over 10 u10 plus c. And we know what u is because here we said it was u. So it would be 1 over 10 1 minus t 10 times this -1. But it's not -1, it's like this. It's like 1 over -1, and you just multiply it in. So anyway, it's like -1 over 10 1 minus t Power of 10, probably. Okay, let's look at the answer. The answer, yeah, that's right. Okay, hold on. Is there a way? Because this isn't the... Is there a way to do this without... without without having it go really badly? Yeah, I can. Okay, maybe I can share this page. Does it really matter? Yeah, it matters. Okay, so here, this is the answer this is what they got, which is negative 1 minus t power of 10 divided by 10 plus c. I forgot the plus c part. Now if I go back to the camera, I basically got that, which is negative 1 over 10, 1 minus t to the power of 10. Okay. Well, good for me. I got the easiest question. I did the easiest question correctly. So congratulations. Okay, so that might mean that I figured it out. I know how to do it. Yeah, easy. It's okay. Don't be alarmed. Don't be afraid. But it's okay. You'll probably learn this soon. And to be honest, maybe I'm making it look really hard because like this stuff I'm supposed to know this like I'm supposed to be very good at this already. But like every time you have like a summer break or something, it just seems like I forget everything. Like I'm not supposed to be at this level right now. If you said that you're like in your third year of high school, like I don't know, don't be scared. Probably don't be scared. Okay, this is x squared plus 1. And so let's say that u equals x squared plus 1. du. Oh, oh yeah, it is. X equals 2x, and then you know a constant gets reduced to nothing, right? Plus 0 dx. Then you're trying to get the dx by itself, so you just divide this du over 2x like this. Then is this supposed to be like this though? I feel like this is x squared plus 1 dx du over 2x. No. Yeah. This is u squared. Here's du 2x. Here's the integral. All you gotta do is pull out 2x. So it's 1 over 2x. Then this goes away. And now you have a very simple integral. Remember the rule before? And like disclaimer, like, watching this to like learn how to do math better. Like don't bother. Just go watch like Khan Academy or something. Got no idea what's going on. 1/3 over u power of 3. Okay. Now we can replace u with what it was before, which is 2x plus 1. Now you got 1 over 2x. 1 over 3. X squared plus 1 cubed. No, this integral is not supposed to be here. And then I think it's supposed to be you multiply 1 over 2 over x by 1 over 3. So that's 1 over 6x. Then you can leave this at the top, x squared plus 1 cubed. Okay, let's see if it's correct. Go to my window. You guys even see it? It might be a little small. Yep, and it was actually completely wrong. Okay, that's wonderful. That's just what I wanted to see. x5 over 5 plus 2x cubed over 3 plus x plus c. Okay, yeah, so this is, actually, maybe I'm not wrong. Maybe they just, like, expanded it strangely. So it would be like, if you took this and you expanded it, it would look like this. X squared plus 1, x squared plus 1. Okay? Which is x4 plus 2x squared. Because, okay, maybe I shouldn't skip steps, but x squared times 1 is x squared. x1 times x squared is 2x squared because you add them together, and then 1, so plus 1, and then here's x squared plus 1 again, which would be x 6 plus x4 plus 2x4 plus 2x squared. Yeah, it was all wrong. Wait, not over till it's over. Plus here 1 times x squared is x squared plus 1. Okay? Now you add them together. So this, okay, so now my work is usually a mess, but plus 3x4. What time is it? So I just have to go somewhere. Well, not soon. What time? 10:30. Yeah, I still have 2 hours. Now you divide everything by 6x. Okay. Yeah, it's definitely wrong. There's no way it's correct. x5 over 6 plus 1 over 2 x cubed plus 1 over 2x plus 1 over 6x. Yeah, okay. Problems, are you trying to find independent variables or do you use them as is? Independent variables. Let's go look at the thing. I hope you can see this. You go here and it says find the antiderivative or evaluate the definite integral. So that basically means, well, you're not trying to find a specific variable. You're supposed to find the integral. If you know what an integral is, do you? Or like, did they teach you that yet? Okay, but anyway. Looks like here there's like a program. Okay. Maybe I can use this program. No. Show f of x. Okay. Well, I can't give up yet. Also, I made a mess everywhere. The piece. Camera. Okay. Maybe there's a better way of figuring this stuff out, and also yeah, I should have reviewed this stuff. Okay, maybe I should just give up and go to an easy. Trigonometric sub. Maybe I should look at the properties. Problem is that I just go different places. Sine, cos. Okay, I don't have to review this stuff at all. Go and get this. Okay, forget it. F of s equals infinity st f of t. The problem is I look at this thing and I don't know what it means. If you want to know what it means, you gotta study integration. Okay. LFT. Also, I'm supposed to be pretty far ahead too. Like 4 chapters. Was G S L I T I S. Okay. Look at what Laplace transform is named in honor of the French mathematician. Okay, what? Okay. Also look like this. Find Laplace of 1, which means that you just have to look at this function, and this is ft, so ft is 1. So that means you have to take the integral of e, just write it down. Integral is infinity to 0, e minus st times 1 basically. Or 1 like this, which is just the limit as b to 0, b approaches infinity, e minus st dt. Okay. Now, okay, I think I kind of get it now, because when you're taking the integral of e, even though I said e to the power of x is the same, e to the power of negative st is not the same. Because the integral of that would be negative e negative st divided by s for some reason. For some reason that I don't know. Okay, and remember that b is infinity. And now you know that the limit as, so t gets replaced with b. So here t is equal to infinity, so it's like this, negative e minus sb, and both of them are over s, and then you get plus 1, because if you take t to 0, e to the power of 0 is 1, and then it's negative 1, and then when you take the two like upper and lower limits, you subtract, so two subtractions make a plus. And then you know that if this goes to infinity, I don't know. If this goes to infinity, it's basically 0, because if I go to, I don't know, e as x approaches infinity, Okay. I have no idea. Somehow this goes away, and you're left with 1 to the power of s for some reason, some mysterious reason that I don't know. Other words, s equals 0. Yeah. Yeah, it's something like as long as s is greater than 0, because if s is bigger than 0, they're saying that the exponent would be negative. The negative exponent is 0 because, okay, no, I know. Because as e approaches infinity, it equals infinity. As e approaches negative infinity, it equals 0. That's what they mean. So basically, for some reason it's approaching negative infinity, and that's why it becomes 0. The use of the limit sign is somewhat tedious. We shall adapt the notation. Okay, and they just wrote it in a... Okay. I think maybe I can figure this out. Maybe I understand. Alright, that's good. Might be getting some... over s. Why? Because... I don't know. Because it's like this. E negative st multiplied by t dt. Then I don't know why they leave the t, to be honest. Maybe it's like this. And then when you take te, I think maybe they ignore the t. And they just divide it by s. Okay. Then we're gonna look at this goes to infinity, goes 0. As t goes to infinity, it would be I don't know. Negative infinity e negative s infinity for s. No idea. It goes to 0. But somehow it's 1 over s. I don't know. Yeah, I'm getting really confused. Just studied harder this year. Saying that it's 1s over s over s squared. Okay. Okay, and now they're asking me to solve my own problem. Yeah, I'm not solving it. C A plus e negative 3t. Okay, if you just pay attention to the whatever, it would be like this. Infinity, 0, e minus st minus 3t. It would be like that because when you multiply e's, it does that. That's the rule. Okay. And it would just be like this over s. And then it would be infinity, so if this was infinity and this was infinity, minus e negative s 0 minus 3 0. Yeah, something about this. I should watch it. I would watch YouTube videos on stream. I'm pretty sure that's for sure copyrighted. That's copyright material for sure. Okay. That's okay. Okay, here's what they did. So my solution is just wrong. I don't know why. Infinity 0 e minus 3t e minus st t equals infinity 0, then e minus s plus 3 t dt. So since they're taking this integral, or it's something like, okay, I don't know, but it goes like this. It just divides s plus 3. I don't know why they ignore t. I don't know anything. And then when it approaches infinity, it's 0. So it would be like this. It would be 0 s plus 3 minus 1 over s plus 3. Because the first time when s goes to infinity, when t goes to negative infinity, I don't know, I thought it was supposed to equal 0. Or I thought it was, yeah, it does equal 0, so it's 0. And then here it's minus 1 because t approaches 0. Okay, yeah, I explained that. And you two subtractions make a positive. Now it's just plus. Okay. Isn't that great? Math fun. Okay. So now b is supposed to be e negative st power of infinity to 0. And it's times e at 6t. So you think about it, it's supposed to be like wouldn't it be s minus 6t? Because it's different. S minus 6 over 1. No, I'm just gonna guess. Yeah, and I was correct. So it looks like pattern that it's supposed to follow is get it. Here, I'll write it out for you. Forever. S minus 6. Okay. I think I almost get it. I almost understand now. Okay, let me write it down here better. 0 minus s minus 6 t. Okay, and this is supposed to be a line. Okay, so basically, when you take an integral, I don't know why, but you divided this, you take this and you bring it down here. So now it would be e over s minus 6, and this still stays up here, s minus 6. But this is infinity, then minus e minus s minus 6, 0 over s minus 6. Okay? And then since you know that, I think the rule they want us to understand is that infinity, when this goes to negative infinity, because this negative is going to go here, it becomes negative. It becomes, as e approaches negative infinity, e will become 0. As e, when you multiply all this to get e to the power 0, e to the power of 0 is 1. So you get s minus 6, and this is 0, so it doesn't matter. And then this is supposed to be a minus, this is a minus, and this is also a minus. So it turns into a plus. Probably. But like if you said that s was like if s equaled 6 or something, it wouldn't work. So s has to be greater than 6. Using definition 4.11. Okay. Find L sine 2t. Okay. That's the part where they start talking about integration by parts. That's the part where that's the part I had to study. A lot of problems with integration by parts. Minus st, and it would be times sine 2t. So why don't I try to review integration by parts? Okay, now I remember. Now I don't. Integration by parts is u dv equals uv minus the derivative, the integral of v du. Okay. Alright. How long has it been? Has it really been 53 minutes? That sucks. I still got an hour and a half to go. Okay. So over here they're talking about L sine 2t equals infinity 0 e minus st sine 2t dt. Okay, yeah, that makes sense. Now, since there's no extra stuff in here, you just take the s and you move it down. So I guess it's supposed to be for s. So negative e negative st sine 2t over s as it goes from infinity to 0. Okay. Plus integration by parts. Wow. 2 over s 0 e minus st cos 2t. Okay. Cool. 2 over s infinity 0 e minus st cos 2t t where s is greater than 0. I'm just copying this so not this. Okay. Alright. 2 over s negative e negative st cosine 2t for s infinity and 0. Sec. Excuse me for a second. Okay. Back. So basically, I think if you look here, if cosine, so we already established that as negative e and s approaches infinity, it becomes 0. And then add 0, cosine of 0 is 0. No, it's not 0. It's 1. It's 1 or something. I gotta look. Sine 0 degrees. Yeah, that's true. It does equal 1. So that's why you get 1 over s times 2 over s. And then you get over here, you get infinity 0. You know infinity goes to 0, so it's 0, here is 0. And then sine of 2t, or sine of 2 is 0, or sine of 0. Sine of 0 equals 0, so I actually don't know. I don't know how. Because this is 1. Sine of 2t is supposed to be 0. Sine 0 degree. Yeah, that's right. So I guess I really do have no idea. Somehow they get... No, that's not true. So for some reason they get 2 over s squared minus 4 over s squared. Times Laplace sine. So now they say that you're supposed to move it over. Oh. Yeah, I still don't get it. Saying that if you move the Laplace sine 2t over, you get something like this. Well, sine 2t equals 2 over s squared plus 4. Yeah, okay. I didn't learn anything from that. Now let's get another piece of paper. Now the integral in question 4 is the Laplace transform of cos 2t. So 3 and 4 show that the Laplace transform sine 2t is a multiple of the Laplace transform of cos 2t. What they're trying to say is L sine 2t equal 2 over s Laplace cos 2t. Thus, with no further work, we should obtain the additional result. L cos 2t equals s over 2 plus sine 2t. Is because when they divided it here, they just flipped it around. It's the reciprocal. That equals s over 2 times 2 for s squared plus 4 equals s over s squared plus 4. S is not greater than 0. Equals. So that makes sense because I don't know. Oh, I do know actually, because these two 2's go away and this is 1 and you multiply this by s. Now it's s over 2 over 4. So what they're trying to say is that let's say Laplace sine 2t equals 2 over s squared plus 4. Laplace cos 2t equals s over s squared plus 4. comes in handy later because, well, actually this doesn't really come in handy because they just give you like this table of like common Laplace transforms. But it's actually, no, it's not, that's not true. It's important to learn how to do them. It's probably important. C denotes the maximum of the two numbers. C1 and C2. S greater than C. Constants A and B can write like this. 0 E negative ST alpha FT beta GT equals alpha infinity 0 E minus ST FT T plus B plus beta. Okay, so basically what they're talking about, they're just talking about you can separate the alpha and beta, which are just constants. So it's like 2, 3, 4, 10 billion, 1 million, whatever number you want. You take it out, and then you just take the function f of t and g of t. It can be any function. It can be like, it can be 2, it can be 2x, it can be cos 2x, or 2t, you know, t, it can be anything. And they're saying you can do the Laplace transformation, probably. Yep, here, they even simplified it. Simplified it so a silly guy like me could understand. Ft plus b beta et equals alpha Laplace ft beta Laplace gt. Okay. Because of the property given in part 5, it's a linear transform. f1 of t, f2 of t, and fn of t. The sum of the transform, the linearity of the Laplace transform. In this example, we use the preceding examples to illustrate the linearity of the Laplace transform. From examples 1 and 2, we know that L1 and LT exist on the interval defined by s is less than 0. S is greater than 0. S is greater than 0. So we can write it like this. So what they're saying is the Laplace of 1 plus 5t, you can write it like this, equals Laplace of 1 plus 5 Laplace of t. So if you guys remember, 1 is equals 1 over s. T equals 1 over s squared. And you just multiply by 5, you get plus 5 over s squared. Okay, that's going to be useful later, probably. For example 3, we saw that Laplace e to the power 6t exists on the interval, but the interval s is greater than 6. And the Laplace of sine of 2t exists on the interval defined by s is greater than 0. Both transforms exist for the common values of s defined by s is greater than 6. And we can write it like this. So it seems that it's important what s means, because if sine t, if s was 0, then it wouldn't work, because I think it would make like sine 0, and if sine 0, then it just equals 0, and it's not gonna work. Okay. So you take this and separate them via the linearity property. And then you do this minus 15 Laplace sine 2t. And we just learned that this is 1 over s minus 6. So you just multiply by 2, so it's 2 over s minus 6. And then plus minus 15 times, because 15 is right here, and it's minus 15. And it would be 1 over s squared plus 4. So you just take this out and take this out, and you just get 15, negative 15. Alright, what a mess. From examples 1, 2, and 3, we have 4s is greater than 0. Okay. How about this? 10 e minus 3t minus 5t plus 8 equals 10 plus e minus 3t minus 5lt plus 8lt. No. All of 1. Okay, so everyone remembers that. Okay, everyone remembers as 10 times this is this. So it looks like it's 1 over s plus 3. Okay, I guess it's like whatever is here, whatever here, if it's a minus, it's a plus, and if it's a plus, it's a minus. Like, that's the rule. There are a bunch of rules for Laplace. Minus 5 times t, 1 over s squared, plus 8 times 1 is 1 over s. So basically it's 10 over s plus 3 minus 5 over s squared plus 8 over s. Okay? There. Awesome. Example 6. Linearity of the Laplace transform. Okay. 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 The next example is linearity of the Laplace transform. So it says find L sine ht. Okay, so this is a hyperbolic sine function. Okay. I'll take a break. Can go to the bathroom, whatever. Yeah. That's my stream. Be back in like 2 minutes or something, or 5 minutes, 10 minutes. So you should do this for homework. How about I just leave this here? Actually, I wasn't gonna leave this here. I was gonna put my screen back on. Do whatever. Look at this picture. Good. Alright, I came back. Okay. You guys figured it out. Okay. The definition of the hyperbolic sign is this. Et minus e minus t over 2 equals 1 over 2 et minus 1 over 2 e minus t. Okay, yeah, that makes sense because he just split the whatever down the bottom. He divided everything by half, so that's why it's 1 over 2. Now you would need to modify the work in parts B and A so that you could get you turn it into Laplace e of t equals 1 over s minus 1 and Laplace e of negative t equals 1 over s plus 1 because this was negative t. Okay. Hence, by the linearity property we have, it would be like this. 1 over 2, 1 over s minus 1, minus 1 over s plus 1, equal 1 over s squared minus 1. Because I don't know. I guess because they just felt like it. No, that's okay, no, I remember why. It would be like this. It would be 1 it would be s minus 1 s plus 1. And it would look like this. S squared minus 1. Because you multiply both of them in. So it would look like this. It would look like s plus 1 over s squared minus 1 minus s minus 1 over s squared minus 1. Okay, then it would be like this. 2 over s squared minus 1 because if you look at it, it's like s and this is minus s minus 1. So this would be minus s minus times minus is plus. So really it's plus minus s plus 1. Minus s and normal s go away. They get cancelled out. And then 1 plus 1 is 2. And you get multiplied by half and this gets cancelled out. And 1 over s squared minus 1. Okay. We state the generalization of the preceding examples by the means of the next theorem. Okay, so you guys can just look up the Laplace table, but I'll just write them down. Like anybody can write the Laplace table. Or like you can just look up the Laplace table and they just give you a bunch of stuff. Sn plus 1 plus of EAT 1 over s minus a plus of sine kt equals k over s squared plus a squared plus cosine kt equals s over s squared plus k squared. Then sine hkt equals k over s squared minus k squared. and cosine hyperbolic over s squared minus k squared. The result of B in theorem 4.11 can be justified for n a positive integer using integration by parts to first show that Tn will n over s plus Tn minus. Okay. Oh, that's great. More extensive list can be found on the table, whatever. Okay, using a trigonometric identity. Okay. Okay, awesome. Page. Using a trigonometric identity, Laplace cosine squared t. Using the half angle formula equals half plus cos t, the linearity property in A and E. We obtain for s is greater than 0. Okay. Just chill. No, not what I want. Okay. We obtain for s equals 0 plus cosine squared t equals plus half plus cos 2t. Okay. Yeah, okay, that makes sense probably. Yeah. Because they're just saying that cos squared equals this. And then you can use the linearity property to separate. So it would be half Laplace 1 plus half Laplace cos 2t. Yeah, well, I'm saying that, but I can literally see the answer on the page. Like, I probably would not have been able to figure that out. So, you know that the Laplace of 1 is 1 over s. You get plus 1 over 2. You know the Laplace of cosine 2t. Just turn around the paper. I already wrote it down here. It's s squared plus kt, where k is what the number is. So since the number is 2, it would be 2 squared, which is 4. So it's times s over s squared plus 4. Now you gotta multiply by 2. So here's this, it's 1 over 2s plus s over 2s squared plus 8. Okay. But that's not really how they wanted to do it. It looks like I did it wrong. Basically, what they want you to do is they want you to do this. They want you to do 1 over s times s over s squared plus 4. where you multiply this into here. So now it would be s squared plus 4 over s squared plus 4, like this, and then it would be, you would combine the things, plus s squared, right? So it would be, so if you move over here, it would be 2s squared plus 4 over s squared plus 4. But don't forget, you need to multiply everything by 1 over 2. So you can just factor this out. 2 goes away. This 2 goes away. You gotta factor everything. So this becomes a 2. It's s squared plus 2 over s squared plus 4. Or you can do like s cubed plus 4s or whatever. I don't know. But it seems like they wrote it this way specifically. Okay. Sufficient conditions for the existence of Laplace f of t. The integral that defines the Laplace transform does not have to converge. For example, neither 1 over Laplace 1 over t nor Laplace ft et squared exists. Okay. We call that a function f is a piecewise continuous on 0, comma, infinity if in any interval defined by, okay. Concept of exponential order is defined in the following manner. A, t1, t2, okay. Well, I did. Okay. E. Okay, yeah, they're showing like some graphs on the thing and I'm just getting really confused. Functions such as ft equals et squared, or e to the power of t to the power of 2. By the additive integral property, interval property of definite intervals. Plus f of t equals 0 st t st f t equals I1 plus I2. Okay. Integral I1 exists because it can be written as a sum of integrals where negative st is continuous. Now f is of exponential order, so there exists constant c m less than 0, t is greater than 0, and t is greater than 0, so that ft equals mect, me to the power of ct, where t is greater than capital T. Okay. A2. Infinity t f of C M P. Okay. And the comparison test. I forgot both of them. Okay. Transform of a piecewise continuous function. Find the plus ft for ft 02 0 d 3 d 3. Okay, so now we gotta find the Laplace of a piecewise function. Okay. Basically that means that plus f of t equals infinity 0 minus st f of t of t 3 0. Oh, so this is how you do those problems. T st. Okay. Negative 2e minus st for s infinity to 3. So it's 0 when it's whatever. You know it's 0 when e approaches negative infinity. So that would be minus the subtraction, it would be plus 2e minus s3, 3s actually, over s. Okay. You shall refrain from stating any restriction on S in the examples. It is understood that S is sufficiently restricted to guarantee the convergence to the appropriate Laplace transform. Through this chapter, we should be concerned primarily with the functions that are both piecewise, continuous, and of exponential order. We know, however, that these two conditions are sufficient but not necessary for the existence of a Laplace transform. The function ft to the power of negative 1 over 2 is not piecewise continuous. Nevertheless, its Laplace transform exists. Okay. That's cool and everything. Looks like now I just finished one chapter and now I have to look at the problems now. So what they were saying before was it would go like this. Go back and look at my note. 0, infinity to 0, and then 3 to 0. Yeah. Back up. 3 to 0. 3 to 0, and then to 3. T is greater than. Okay, so it would look something like this. 1, 0, infinity to 1. Get of S. Get S. Yep. 1. ST. Alright, so basically that means that does probably like this. 1, 0, ST, S. It's also negative. Negative like this times negative 1. It would be positive. Then minus plus 0 is ST S 1 is 1. So it would be ST e to the negative S over S minus the power of 0 over S, which is 1. 2 plus infinity is 0 minus, this is also probably plus, and now it's plus the power of 0 is also 1 over S. So E minus S over S minus 1 over S plus 1 over S. Do these go away? Okay. Guess I have to go check the answer key. .1. The question. Okay. Well, I was pretty close. 2 over S E Okay, so I wasn't close at all, basically. Okay, let's take a look where I went wrong. Okay. Well, anyway, that wasn't the kind of questions I was supposed to practice. Okay. It looks like get rid of this. It's supposed to be ft equals et plus 7. And you're supposed to take the laplace. Okay. So if you do that, I'm pretty sure you can do. It's not gonna work. Probably do it like this. It's gonna be like this. T7. Okay, so now all you have to do is T7 minus S. Also gonna be negative. One over S minus 7. Pretty sure it's supposed to. I was. Oh, okay. I just go to that website. Okay. The plus. So I actually was. You were supposed to do that. Supposed to do et plus 7. T is, and you're just supposed to leave e to the power of 7 for some reason. Possible to take loss of e to the power of 7. S. Okay, there. See if I can do the next correct. Ran out of paper. I used paper. Okay, I gotta write smaller. FT minus, do this class. Okay, do this, you get a minus st minus, get this, you s minus the negative plus, and have s is supposed to be, was it t is negative, it's actually good. S minus 2, negative t, which is it's 1, so you got 1 over. It's correct. Multiply by s minus 2. S minus, definitely. So no answer. Oh yeah, I have symbol lab. Okay. Power of definitely. I got the 1 over s plus 2 part right. For some reason, it's 1 over e to the power of 5. Okay. Question 19. Laplace of d8 s5. Oh, that's wrong. Answer. FT. Have to do that. Plus. Okay. So you get 2 Laplace 4. So it's like this. It's 4 exclamation mark s plus 1. Right? T and t power 4 is Sn, so it is T5. And 4, the, what's this called? Factorial. 4 times 3 times 2, 12. 2 is 24 times 1 is 24. Got 24 over S5. Don't forget the 2. Now you multiply the 2 and then you get 48 over S5. Okay, that's the first one I actually knew. So, it's a pretty good day. One more than I usually get right. T plus 1. Okay. 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 What I say we're gonna do, we're gonna solve this problem. What if I did it like this? T plus t cubed plus Laplace 1 cubed. That's not how math works, I think. Pretty sure that's kind of and t squared times 2t 1 cubed plus squared 2t squared plus t plus t plus. Okay, there. Now you gotta wrap it all together. Cubed plus 3t squared 3t plus 1. Okay, and now you can take the Laplace of every single one of them. It's like this. Plus t cubed plus, is that a 3? Yeah, 3 Laplace t squared plus 3 Laplace t plus Laplace 1. Okay, and this is pretty easy because you know 3 times 2 times 1, what is it? 6. 6 over S4 plus 2 times 1 is 2 plus whatever is 6 over S3 plus t 1 over t squared times 3 is 3 plus 1 is 1 over s. Now if you go there, and actually this is s squared. Okay, now let's take a look at question 19. Question 25. 6 over s4 plus 6 over s to the power 3 plus 3 over s to the power of 2 plus 1 over s. Hooray, 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 I did it. Correct. Okay. 29, 31. Okay, so question 39 and question 29. Like this. F of t 1 plus e 2t squared. Okay. Okay. 1 plus 2t 1 plus 2t. Just multiply them, you get 1 plus 2e 2t plus e4t squared. Damn. Is that real? It is. So, got the Laplace of 1 plus 2 plus of e2t plus plus of e4t squared. Okay. Okie dokie. Second to think. And drink of water too. Probably in around 15 minutes I'll have to leave. It'll be right around the 2-hour mark, so. Okay. So the Laplace of e to the power of 2t is what? I have no idea. Okay. I cheat. Sorry. Laplace e of at equals 1 over s minus a equals 1 over s minus 2. Okay. Now the Laplace of 4t squared. I don't know. I guess I'll put in its calculator. It says they don't have any solutions. Okay, so obviously, looks like I messed up pretty bad. Plus e2t. Yep. Okay, it wasn't 4t squared, it was just 4t. But how is that possible or even allowed? Because it should be 4t squared. Because if you take 2t times 2t, it's 4t squared. Okay, I guess I'm just silly Billy. I guess I'm just a silly guy, but okay, if you look over here, this is not t squared. So if you look over here, it's 1 over s plus 2 over s minus 2 plus 1 over s minus 4. This is the answer. If you take a look at 29, yeah, that's right. The correct answer. Okay, and then question 31. Ft equals 4t squared minus 5 sine. Okay. Okay. Okay, so it will be Laplace or Laplace t squared minus 5 Laplace sine 3. If you guys remember, sine 3t is 3 over s squared plus 9, I think. Probably. And this is t squared. It's 1 times 2, or it's 2 exclamation s cubed. 2 times 1 is 2 times 4 is 8 over s cubed minus 15 s squared plus 9. This should be the answer. But look, I was right. I was right. Getting pretty good at this. Solve LT by first using a trigonometric. I lied. Equals sine 3t cos t. Okay. I literally forgot all of my trigonometric identity. Okay, let's go look it up. Trigonometric identity. Okay. This is Wikipedia. Never trust Wikipedia. Because I said so, okay? Okay. Yeah. I figured it out. Okay. Well, that's basically me having done most of the questions. But it's probably not enough. I'm gonna have to do some more review. So sooner or later, that was just part 1 definition of the Laplace transform. I still have like 3 chapters left. Not just 3 chapters. I wish I had 3 chapters. I have 1, 2, 3, 4, 5. I have to complete 5 chapters. And then I haven't even gotten started on the Fourier. I'm done for. I'm actually done for. Okay. I'm dead. No. I'm not dead. But I'm pretty close. Plus I have a test due soon. Oh man. All kinds of. Okay. Wish I could finish off these drawing some. Every stream I open up with a picture of something that I drew because I want to get better at art. Do it every day. Gonna get better, right? Everybody left. Ton of people in this. 4 people. So that's the all-time high. Like higher than it is usually. 4 people. So shout out to everybody watching. Share, like, and subscribe. Follow. Donate me money. Okay. Bye bye.